Hi, my name is Mr. Lewis, and this is our very first lesson for geometry. This lesson is about constructing equilateral triangles with a compass and straight edge. And this video is made to prepare you for that discussion and those activities that will happen during class. In this lesson, we will address two college and career readiness standards, or CCRSM standards. The first is to know the precise definitions of circle and line segment based on the undefined notions of point, line, distance along a line, and distance around a circular arc. Those definitions are given to you in this video, and so please pay attention to those two definitions, especially the precise nature of those definitions, and be prepared to memorize those because you'll be asked about that and assessed on that later on throughout the year. The second standard that we're addressing is to construct an equilateral triangle and a regular hexagon. Now, we will do that more during class, but I want you to be aware that that is what is in the standard, and therefore we'll focus on that during class the next time we meet. You should have in front of you the student materials for Module 1. This video and most of my videos will go along with the student materials. I want you to write your notes directly into your student materials so that becomes a powerful resource as we address the CCRSM, the College and Career Readiness Standards for Mathematics. This first lesson, again, is about constructing equilateral triangles, which we'll do during class. I want to start with these vocabulary terms. The blank between points A and B is the set consisting of A, B, and all points on the line AB between A and B. Now we will start to understand this definition by focusing on the fact that it's on the line AB, which we'll later learn should be written like this. So you can go ahead and draw that in to your notes. On line AB. So there's a line that'll go on forever in both directions. And on that line are 2 points. One point is called A, and the other point is called B. We know that because it says line AB, and that means that those 2 points are on that line. Now, this term is about the points A and B, so I'm including points A and B, and the set consisting of those points and all the points in between them. Well, I'm sure that you know that this is a line segment. Okay, before we move on, I want to talk briefly about this word, set. Right? It's a very mathematical term. It has to do with a collection of elements or objects. It could be numbers, it could be points, it could be something. In this case, they're points. All right? So every single point that's in between A and B, including A and B, is a set, and that collection of points is the line segment. Okay? So there's a little bit of a precise definition there with the term set being used, but it's a collection of points, and it's every single point that's on that line in between A and B, including A and B. Okay? Our next definition is a segment from the center of a circle to a point on the circle. So here's a circle, here's the center, and here is a point on the circle, and that segment is called the radius. All right, the third definition is given a point C in the plane and a number R, which is greater than 0, the blank with center C and radius R is the set of all points in the plane that are distance R from point C. Now I'll label this point C and call this R, and you won't be surprised to know that this is a circle. Yeah, the definition of a circle is all the points that are distance R away from point C that are in that plane. Okay? Now I know that you know what a circle is, but that definition might be more precise than you're used to. Now I want you to put a star next to A and C. And the reason for that is these two definitions are directly from our standards, that you know the precise definitions of line segment and circle. We will take some time during class to memorize these, but you can already begin looking at them and trying to get an idea for what they mean, internalizing them so it's easier for you to memorize these two terms. We will do the sitting cats activity during class. We will not take very much time with Euclid's Proposition 1, but I do want to take a second and explain who Euclid was. Euclid was a mathematician, a Greek mathematician, a long time ago, and he did something that was pretty amazing. He organized the entire body of knowledge of geometry into 13 books and did it in a very systematic and logical way, and started with 5 postulates, 5 basic truths, and began to prove everything based on those 5 postulates and every theorem he's proved so far. It was very systematic, very logical, and I believe that those foundations of how that was done was later replicated in many fields of study. We will do the exact same thing and begin by basing our study of geometry on some postulates, on some assumptions, and then begin to derive everything from there. So I want you to begin by reading just the first paragraph in this geometry assumptions, and think about and look for what role does assumptions play in geometry. Ready, set, go. Thank you for reading that. Just as in any field, there are facts and definitions that we assume to be true, and we'll base everything based on those assumptions and definitions and facts, and the same is true for geometry. Now let's move on and talk about some relevant vocabulary. I first want you to read through the definitions on this page and the next page. You can just skim through them, looking for terms that are new to you. Okay, ready, set, go. Thank you. Geometric construction is the focus of this first topic in Module 1. We will do a lot of constructions. A construction is where you use a straight edge, which is like a ruler, but it has no length measurements on it, and a compass, which I'm sure you've used before, which is used to draw, circles and parts of circles called arcs. A set of instructions where you make something is called a geometric construction. A figure is a set of points in the plane, just like a segment, but a figure is what we use to talk about things like triangles, squares, rectangles, and other figures or other things in the plane. An equilateral triangle, I draw a picture, is a triangle where all 3 sides have the same length. I'm sure you've seen these before. The next one might be a new term for you. The term is collinear. 3 or more points are collinear if there's a line containing all of the points. Otherwise, the points are non-collinear. This comes from 2 root words, co, meaning same, and linear, meaning line. So collinear means same line. Let me give you some examples and non-examples of this, as many students are confused about the term collinear. So here's a quick diagram. So points A, B, and C are collinear because they're on the same line. Points A, B, and G, are not collinear, are non-collinear, because they're not on the same line. Points E, G, and B are collinear because they're on the same line. And D, F, and C are non-collinear because they're not on the same line. All right, hopefully that's enough examples and non-examples to help you get an idea for what collinear means. Next, we have length of a segment. The length of segment AB is the distance from A to B and is denoted AB with nothing written on the top. Thus, distance AB is equal to the distance from A to B, writing it a different way. We will talk more about distance at the bottom of this page when we talk about coordinate system of a line, because that's where distance comes from. The thing to point out right now is that segment AB and distance AB and line AB, that these three notations are all different. And it's very important that you're very precise in your notation. Go ahead and write a phrase for me in your notes that clear notation produces or yields clear thinking. I believe that if you are sloppy in your notation, you will also be sloppy in your thinking. If you're clear in how you write things and name things, then you'll be clear in your thinking. All right? Now, let me point out that there are no arrows here, meaning that it starts and ends somewhere, like a segment does. There's nothing here because it's a distance. And distance isn't a figure in the plane, it's just the length of something, and so there's no figure above it. And here we have two arrows reminding us that a line will go on forever in both directions. Okay? Now, it won't surprise you that you can add distances together because they're not points, they are lengths or numbers. This right here, these two lines, means parallel. And I will also talk about a ray. So a ray is part of a line that starts somewhere and then goes on forever in one direction. So ray AB will start at A and then go in the direction of B. So here's A, here's B. The ray starts at A and then goes on forever through B and past B forever. Okay, this arrow always points to the right. All right, the last idea, the last vocabulary word is coordinate system of a line. Given a line L, so here is a line L, a coordinate system on L is a correspondence between the points on the line and the real numbers, meaning 1, 2, 3, pi, all the numbers that you can think of are real numbers, such that to every point on L, there corresponds exactly one real number. So for example, -2, -1, 0, 1, 2, 3, 4, to give you a very simple example. And to every real number, there corresponds exactly 1 point. The distance between 2 points on line L, so the distance from here to here, is equal to the absolute value of the difference of the corresponding numbers. So the distance is equal to the difference between, I'll say B minus A, the difference between the coordinates. So for example, the distance here can either be 3 minus a -1, which is 4. Whoops. Or you can think of it as -1 minus 3, which is -4, which is 4. Either way, the order doesn't matter so much. And you will get the distance of 4. So this line segment has a distance of 4. And the same is true no matter what two coordinates you use. Distance is given by the difference between the corresponding coordinates. Okay, and that's a coordinate system in that every line, has a correspondence between the real numbers and every point on that line. Okay, so this video was just some basic ideas, some vocabulary words, and some underlying assumptions to prepare you for our discussion activities in class that'll focus on how to construct equilateral triangles. Thank you so much for watching.